So good morning, everyone. I'm really surprised that you want to learn about the power of graph databases. I might think that you probably know already something about it, and this is more like an introduction talk, so I will maybe highlight some things which might be very interesting for you if you start to create a project. Well, the thing about me, I'm a guy from Switzerland. I try to be a software craftsman as good as possible. You know, it's quite hard to do that. So I try also to coach teams actually get better in their daily job. And I also do some technical things like working with the Spring Framework, working with Neo4j, a graph database. And I'm also heavily involved in the community. So that means we run in Zurich monthly a software craftsmanship meetup where we do, for example, a lot of workshops. That means just not talks like here, but hands-on all the time, so you can learn from your peers. And that's really awesome. So, and as you also can see on the slide, I'm involved in Voxed Zurich. So, call for papers just started. So if you have a topic, just go to the website, participate, and, well, we might see each other in March in Zurich. The rough agenda we have is, well, yes, this one? No? It's more like the introduction into graphs. What is it about? Then also maybe we have to find out actually what do we use graphs for? And then we just take an example. I just really say it's an example that we talk about Neo because I know that best. And then also, hey, how can you use a graph database in your projects? Actually, what do you do there? So these are like the next steps we have to talk about. So in general, when we talk about graph databases, we actually know it's a NoSQL database. So it's typically not a relational database, and we have the thing that graphs are highly connected, and the thing about the graph database is that it's about complex data, which is connected. So if we have like a cache where we just have a key and a value, we don't need a graph at all. It's best to have a key value store just to store the things like in a map, and that's it. But if you have afterwards things which are highly connected and we have to get a meaning out of these connections, then a graph database is actually the right thing. So the graph databases, well, it's here, you see that. Data size is probably not as high as in a key value store, but, well, it's interesting because we can make sense of data. So if you do your projects, actually, it might be that you could use a graph database. Maybe you don't have to because there is no need yet, right? But now we will see actually where things will start, where you might have to think about the graph database. So a graph database is not something like you see on the screen here. It's about storing the data, querying the data. It's not a graphical representation of the data. So usually you just see some nice pictures like this, and you think, wow, it's a graph, and maybe it's just, that's the graph database. But that's not true. So the graph database actually consists of a few components. So we have a model called property graph model. So we have nodes. We have relationships between the nodes. Then we have the properties. And the properties can be really everywhere. So that means you can store the data on the nodes or the relationships. And sometimes, because it's very handy, you have labels for things. So you actually can tag your nodes like in Gmail. You actually tag your emails, right? So this is actually the base data model we have. So it's highly flexible, and you have actually to know what you're modeling and how. We just have those components. So with a relational database background, you might think of yeah, actually, how could I transform that? And I would love to show you how this could look like. So it's just an easy example, just to show you, hey, we have the same thing actually in a relational database, but if you get more familiar with the topic, you just forget about the relational database, and you just start modeling the graph, and do it that way that your queries get fast. So let's have a look at 3 tables. So we have a person, or we have a person table, we have a company, and we have something in between. And can you spot now the nodes and the relationships? Well, it's quite an easy example, so just that you get the idea. Well, we have the nodes like persons and company, and the other thing would be the relationship in between. And you see also, I just changed the name of this mapping table so that we have a better naming. So actually we transform this model into a graph model. If I draw that a little bit different, then it just starts looking like this here. So we have nodes, the same thing, we name the relationship with a proper name, so actually it can have a meaningful name, so we can build like a sentence when we read it. And we have these bubbles and this data somewhere. And this is actually a graph database. Now the things are not connected because, well, we don't have enough data. Maybe we should have more data. We could put some data inside, like who sent whom an email. Or for example, if you do that with an online shop, you have like purchases. You just would go and add those things like crazy. And then you really see that we add different levels of meanings to that model. So, wow. Now we have just a different data model. But what's actually the power? What's the killer criteria to use a graph database than a relational data model? What I showed you just before, it's nothing, right? So it's just like the same thing, but different. But now, actually, when you start doing queries, and, well, sometimes they really get slow because you have to do a lot of joins and so on, then you might think of, hey, a graph would be nice. So a relational database has a huge problem. It has the problem that we have to join data. We have to join the data all the time when we actually want to traverse or actually make queries in the system. So we are loading data like crazy, join them, and then afterwards we have the result set. On the other side, in the graph database, actually you don't have this problem because you do the joining of the data during the creation of the data. That means you actually store the data like a graph. So in the end, if you write a query, you just like hop from one node to the other, right? So for example, if you think of Facebook, and you have an example like, give me the friends of friends of friends of friends, and so on, wow, a relational database would take ages to get a result. But in a graph database, it's just a few hops you do, and it's just a few milliseconds in the end. So this is just a huge difference, actually, you have. So actually, when we do our projects, we have to think of where is our data, where we can put the data to make our queries fast, right? And this leads us then to our use cases. So actually, what are the typical use cases in a graph? So just like, hey, use cases, where do we have actually graph when you think of our reality? We all know about the social graph from Facebook. We all know of the knowledge graph from Google, right? These are just 2 examples. These are very nice examples because they make a lot of advertisement for graph databases. So a social graph where you connect all the things we know. We have LinkedIn, we have Facebook, we have other social networks we can actually apply those things. So actually social data is one of the biggest thing we just easily see in the market. Typical use cases also. But the other thing would be, hey, where do we have also such kind of relations, data connected and so on? And there is the next one, it's called the spatial data, so where we connect places, routes, and so on. So you can think of a network, of a train network, or of a street network. Or for example, if you do some routing of parcels in the world, like you do with DHL, for example, it's a typical use case, so they have to find the cheapest route to the place. So such things are really typical. Now there is another topic which is very hot at the moment. And people are like crazy about this financial data, especially about fraud detection. So you can think of a bank and, well, they will lose a lot of money, actually. And they have a lot of projects going on in this area because if you don't lose the money, you can spend it on the project, right? So it's actually easy to tell them, hey, you have this amount of money you would lose, but you could spend it and then you don't have it the next year. So that's actually a great thing. And in some places, you have those kind of data. So maybe the bank is not just enough, but if you think of some, not companies, but authorities which do regulations and they have all the market data, it's actually a very very nice playground. Right? Okay. So there is another thing, and I'm sure you saw that already when you used Facebook, for example. It's this recommendation thingy. So they are suggesting you all the time in Facebook, your colleague actually bought this product and it would be something for you. So recommendations, because you have people, you have maybe products, you have categories, you just do some queries and you will find out what are the similarities between those persons. So it makes also sense to apply those things in a graph database. But I'm sure you still might say, hey, we do that differently. That's totally okay. It's just like one of the playgrounds for graph databases as well. And there is another thing called impact analysis. So where we have actually physical networks. Well, you might have servers in your company, you have a network, you have a SAP, you have a web shop. You can actually model that as well as a graph. And then if you have a problem, you can actually easily find out which systems are involved. So a lot of companies do that. For example, telcos do that. Telecom or TV distribution networks, they do the same because there it's quite difficult. So it's just another way where you can find graphs. But I told you now about those typical use cases, and they're quite simple if you look at it. But actually, if you would go and add some other things to it, it's becoming more interesting. So for example, if you mix things up like social data and spatial data, you could do something like a hotel recommendation platform, and you know the users, you know their preferences, and so on. So it just adds another layer of this nice nitty-gritty thingy, which brings a lot of value. But how would you do that in a relational database? It gets difficult, right? So mixing things is one of the interesting parts. For example, if you start a new company, start a startup, then you start mixing those things. But just like those use cases I told you a little bit about, are they the only ones? What do you think? Probably not. So, I mean, we are all developers. Can you think of a graph in your source code? You could actually do queries how your code is built, right? You could use rules and enforce some practices to do just with your source code, because source code is also data. It's nothing else. It's just data, but the special type of data. Or, for example, I was talking yesterday to a guy on the Seven Bridges booth, and I was asking them what they actually do. And they say they are building tools to analyze the human genome, right? So, wow, there we have actually also a graph. So actually you can do things in the graph. You have these parts of the DNA. You can map them together. How cool is that? So if you maybe just take a few seconds, where in your company could you find graphs as well? I don't need any answers, so just, well, you will find them everywhere if you just start thinking of graphs, because everything is highly connected. Okay, so this is actually the message I want to tell you. So if you start thinking with graphs, everything will be a graph. So when you start in a project, graphs are so powerful, but how do you actually start? And when you talk to the people from all those graph database companies, then they tell you just use a whiteboard to start. It's that simple easy. And it's even that easy that I can speak to a person from the business who has no technical knowledge, and we just go to the whiteboard and we start sketching something together, right? I don't have to teach them UML. There is no need for it. Just some bubbles and lines, and that's it. It's that simple. So usually when I try to explain how I would start a project, I take an example I like very much and has nothing to do with business, right? So I just built a while ago something called a single malt whiskey graph. And I was actually tweeting about that because I hoped somebody will approach me and will ask me how this looks like so I can demo that. So you have still time to do that because I can't do that in the session. So the single malt whiskey graph was just for me like a way to explore new whiskies from Scotland. And if you start doing that, you have actually to find those data. But you can easily transfer this knowledge now to a business case. I mean, let's do a portal where you actually sell whiskies. Why not? And then I started to sketch. And whiskey, of course, it's a thing, it's an entity, it's a node in the whole system. A whiskey has some flavors. So there are some books about it, some categories you can apply. You really get those data about the whiskey, which describes a whiskey. So just taste. Is it smoky or not? Does it have like citrus flavor and so on? So it just could be also every other kind of drink. Then when you talk about single malts, then usually you categorize them as well by location. So you say, well, it's from that town in that region. So that's why I started to combine that then that way. So because there are people like me loving heavy smoky whiskies, and that's on Isla. So that's actually a region on the islands, on the small islands, and there are a few distilleries. So you just would go there and try to find a thing. So actually what you're doing now is creating a meta model for your data. A meta model you can discuss with your colleagues easily on the whiteboard, even if it's bigger than that. And then afterwards, if you try to verify if your data is still consistent, you can actually use this meta model all the time and actually go through the graph and just try to find out if it still matches this pattern. if you start then building up your data, things will start to look like this. So you will have plenty of nodes, plenty of relationship, highly connected. And you would actually have to do queries on it. There is a URL on it, on the slide. Maybe I just jump over because it's documented in the web as well. And need to see if this works. So it's documented on the web in a form that actually it's executed all the time. You can actually build your own queries if you want. It's actually quite easy. And what you can see is even the pictures with the meta model is there. The graph here is flickering because it's JavaScript. It's live evaluated. And then you actually start writing some queries to get some data. I'm not diving into that yet, how you do the queries, but actually, if you want to find queries like Artback, then you would define a query which matches the pattern. So Artback is a smoky one. It's probably in a category for the smoky ones. You just go to this node, grab this one, and then try to find the whiskey nodes around this category node. So this is actually the idea in the end. So, but we just did the modeling part of it. And you can see inside we have roughly 70 whiskey types at the moment, and it's a really nice thing to play with. So if you're interested into the topic, approach me after the talk and we can do your queries together. So, the next step is actually, we did the modeling, but we haven't talked about graph databases yet. I mean, not so much, just about the data model actually. And if you go and search for graph database, it's like a huge zoo, and they are all very different. Some databases tell, well, we have a graph API. Some say we are a native graph. So for example, the one you can see on top here, they actually store the data like a graph. So it's stored with all the relations in the database. But there are other graph databases. So for example, these ones here, they use a different format. But there are just a few of them at the moment, right? We'll see afterwards a few more. So they store that in a different format. Might be in a document, for example. But that's not the same thing if you store that in a document. That's why here we have also the axis for the graph processing. So you actually run through the graph in reality, or you do some other kind of calculations to achieve the same result. These are just a few of them, and there are much more. So I just tried to find a few of them, and I'm sure you recognize some brands. They have all different approaches, and it's very important before you start a project that to actually choose the right one. So you have to think of, do I have a lot of data? Is my graph highly connected? Does everything fit into a single JVM? Do I have to distribute that for computation, maybe, because I have so much data? Or, yeah, there are quite a lot of questions you have to ask yourself. Well, the other question would be, can I shard my graph at all? Some can, some can't. So it really depends what you're doing. So just what I want to tell you here is a graph database is not just like a graph database. There are so many and their behavior is so totally different. So there is actually a reason why there are so many logos on the slide. And even MongoDB says they have a graph API, right? So the one I use in my project is the Neo4j thing. The database, which is based on Java, so I can actually write plugins for it if needed. So I can really dive into the database, do some extensions, and so on. So that's actually quite nice for the things I do. In Neo4j, what you usually start with, you will see the browser. And yes, this is a graphical representation. And not these bubbles are not the real bubbles in the database. It's just like JavaScript visualization. So that's the thing you start play with and get a feeling for it. So when you look at this product, I don't want to make too much advertisement for it. It's just Java-based. It's like it's running in a single JVM. Has its limitations, of course, but it's probably one of the oldest graph database which are not based on the RDF model. And they have also different licensing, so I just have to tell you this as a developer. If they say they are open source, you have to look twice, because if you build a product on it, then you have to pay for it, right? So Neo, for example, has the approach in general, if you make business out of this thing you are building, then they want their cut as well. But that's okay, I think. But just like as a developer in general, check the licenses. It's an important thing. Neo is not like all the other NoSQL databases, because there is a huge difference. They say they have transactions. Most of the NoSQL databases claim we use base, eventually consistency, and not transactions. But in Neo, it's different. We have real transactions, transaction boundaries, and so on. We use node objects and relation objects actually to combine that inside the database. You might not see that if you don't want to, but if you dive into it, you will see it. You can have billions of nodes and relationships. But if you have so much data to process, like you want to analyze the human genome, maybe Neo is not the right thing for you, right? So we have everywhere limitations. And the other thing is, because it runs in one single JVM, and you just put more memory and more CPU inside, it's quite fast. So if we would have a cluster and we would have to jump across the nodes, actually we would have latency time in the network that wouldn't be fast. But because Neo is running just in one JVM, we can be really, really fast. So just a few ideas about the graph database you have to think of when you start your project. Well, one of the big questions when you do querying in a graph is, how actually do I do that? What kind of queries make really sense? In a graph database, it's everything about finding structures, finding a pattern you defined before. So as we saw with the whiskey, we might have just something like an L, things connected. We might look for a pattern like on the slide as well. But is it always that simple? Well, it's not, but it can get complicated. So in general, in a graph database, you actually look for graph local searches. That means you have the entry point somewhere, and from there you actually start doing your queries. If you would say something like, give me all the whiskeys in this graph, well, you would have to traverse the whole graph. That's not fast. But if you go and say, give me the whiskey of a specific type, then you actually start at the type, and then you just go around and traverse those nodes. So that's the idea. You try to avoid as much as possible graph global searches because they are so expensive. Okay. So, well, okay, another idea we have to think of. When we query a graph, there are a lot of ways to do that. Even in a graph database like Neo4j, there are several APIs you can use. If you think of something like you're a Java developer, you want to write Java code, that's possible if you write a plugin. But for example, for somebody who is more like on the business side, they would search for something which is like SQL, maybe they know that already. So there is a query language called Cipher they support. And I mean, from graph theory, we know already about graph algorithms like Dijkstra, like A*, and so on. So actually we want to use them as well. You don't have to implement them because they're already in the graph database, so just you can reuse it. To get access to a node where you want to start your graph local search, you should have a thing like a Lucene index. You can actually ask the index for a certain thing, for a certain node to start, and this is then also called index queries. So they have internally an index, so we can find the entry point very easily. Yeah. If we look at the Java API, it's just an example here. Pure Java code, you see we have relationships, we have relationship types. Actually, it's just Java objects you can traverse in. But yes, that's not so nice. It's maybe overcomplicated. But if you have to be very, very, very fast, you have to do it like this. There is no way around. But there is something I just mentioned before, the Cipher query language, which just gets better and better all the time. So that means they are creating out of this query language Java objects at runtime. So this just will be a way to be as fast as the Java code you write yourself. So the Cipher query language is actually something which is very nice, and I will just jump to the next slide because it's just very expressive. It's called, or they're using something called ASCII art. You're actually drawing a pattern. And this is just an example how complicated it could look like, what kind of elements you could use. But what you can see on the top here is we have here the node, that's the bubble. We have here the arrow, it's the relationship. You can provide the relationship a type, a name, and you just put it into these brackets here. And on the other side, you have another node. So you are actually defining the pattern from node over relationship to the next node, to the next relationship, to the next node, and so on. You can build circles. You can actually provide any pattern you want. And then, like in SQL, you have some things like the where clause, where you define some things, or you define the part where you return actually the values afterwards. You might sort them and so on, and even limit them. Cipher is a very powerful language, so you can easily start with, so it's a great thing actually. But there is something which is just starting to get more attraction. So with Cipher, we have REST endpoints to the database. So that means you can actually use any kind of language, have a special driver, and the driver talks to the database. So C#, JavaScript, Node, Ruby, and so on. Java, of course, as well. So there are a lot of drivers that are available, maintained from the community. So in general, the Cipher endpoints, they are really fast. But there are some problems. If you want to load a lot, then something like a binary protocol would be very nice. And that's something they start to implement at the moment. So that everything gets more compact, but you still write actually Cipher, and the driver uses this binary protocol to talk to the database. So it's just ways how you can write queries with an example and so on. But we talked about the database and the querying. But hey, we need some data, right? How actually do I get some data into the database? We saw the match statement before. To query, well, Cipher is almost or probably Turing complete, so you actually can create objects. You could do it like this. We have here a statement where you create a node with a name Alice. Then you would just create one. You would create a node and a relationship in between. So we just go and create another node, and we add the relationship to it, and then we get this one here. Or we just write things like this here. Actually, the curly braces, these are the properties on the nodes and the relationships as well. And we can create something like this in Cipher. Just create statements you could use to create data, but that's actually not enough. It's not enough because you want to import data, a lot of data. And what if the data already exists? So besides the create statement, there is a merge statement, and the merge statement actually says something like, if it not exists, then create that one. It also matches for relationships. So if the relationship is not there, like you specified it, it just will create another one. But yes, you would have to generate those merge statements, right? You would have to write some code. It's still not that good. And there are other tools, for example, if you try to export the data, like this load CSV, it's extract, transform, and load mechanism, how to actually get CSV data into a database. So, for example, this load CSV, you just can provide a URL. It could be also a file on the file system. And then you provide here a template, how you're actually going to create those objects in the database. So it's just a good way, actually, to import a lot of data. Well, this one has a drawback, because you do that with an up and running database. So if you have like 10 million nodes you want to load, it's just okay. If you want to import like 100 million or even more, then you should think of creating the data without the running database. So Neo4j also provides something like this, so you can actually create the files for the file system for the database without all the transactions, because here you get the transactions and then it's very slow. So that's the thing about the graph database, right? And loading data, and we saw actually we can query it and so on. But, well, the graph database, is the graph database your single truth of the data? What kind of data do you have in your company, or do you need for your customers? You have maybe financial data, you have other data. You can't replace those systems because other applications are using them. So that means actually in real world we have a lot of data around. And probably you heard already about this Polyglot Persistence. That means you have a lot of different data stores and you just have to combine them. So when you think of a real world example, like a web shop like here on the slide, you would use a key value store for sessions. Well, maybe a key value store for a shopping cart. If you're doing recommendations, we learned it's a typical use case for a graph database. If you have a product catalog for your products you're selling, well, it looks more like a document. If you do some analysis of the usage of your platform, then maybe it's something like Cassandra. And, well, there is some data around in your company you never get rid of. It's the financial data, the customer data. So you will always have some kind of relational database in your system, probably. If you can't start a greenfield project, of course, but usually you can't totally start from the beginning, right? So my question is then, like, what is a graph database then? Is it just a tool, or it's maybe a data store, or is it both? Or consultants would say maybe it depends, right? Yeah, it's a really good question, actually. Nowadays, when you think of creating, I mean, I'm just switching now the idea. When you're thinking of a data center, you try to use Docker, you spin off a lot of Docker containers. You actually build systems that you easily can throw away data, right? All the time. And probably you would do something similar with a graph database as well. So you would use it as a tool. You would overnight maybe load the data into the graph database, do your queries on it, do your calculations on it, because it's very fast compared to relational database, and then afterwards you're throwing it away. So then you would look at it like a tool for fast calculation on some metadata. You wouldn't store everything inside. I mean, a graph database is not made to store images, for example, right? It's just about metadata, it's about text, it's about the relations between the objects. Images you would store somewhere else, probably, yeah. So it's something, it depends on your project, on your use case. I have friends, they are doing a product with Neo4j, and it's the only database. Even financial data is in Neo4j, but others are really just doing calculations on it. Okay, so graph databases are a very nice topic. And the other thing is you can actually get a lot of information if you want to. So, for example, the community in general doesn't have to be on Stack Overflow, is really vibrating. They build products even for developers. I told you before a use case could be something like analyzing your source code. There is a tool, and I have also a sticker on my notebook. It's called JQ Assistant, this one here. It's based on Neo4j, and they are analyzing, and you actually can enforce in your architecture that the things are built corresponding to those rules. Or there are other products in the community building on this, like this Structure. Structure is a web a CMS. So they just say, hey, all the files we have, like the HTML files, well, we have inside nodes there, so let's represent the HTML tag as a node, right? There is a lot actually going on. So just go and maybe even look for a meetup group or people who are like in this space and talk about that. So, getting to the last point here. Can you read that? It's ASCII art, and even my mother would understand that, right? Yeah?
What about clustering? What is the simplest way to, how to say, these graphs are in one cluster, these are in the second, etc., etc.? I've seen in your example that you are using types, like a subproperty or something. Is it hard to say a faster way where when we query, we will not have to find, to go into the structure of the graph to find to which cluster it belongs?
You mean clustering like grouping the objects? I'm glad he asked that, because the other thing, clustering like in production, is another big topic. But yes, you saw that we were using in the example labels. So it's like a structural grouping of the elements. So that means you actually can just go and say, I want to have nodes of this type, and you don't have to search for all the nodes in the database and then afterwards sorting that. So actually that's the mechanism to easily find those specific nodes. And also in the Cipher queries, actually, when you're using the labels, it makes your query much faster, because as I said, they are just like in this group, and no other node will be actually be part of this query. So that's actually the idea. The other thing I first meant he wants to talk about was the clustering, like how you cluster a graph, right? So having, well, a shard for cluster, like parts on this side, parts on that side, and that's so difficult to do it right. There are different databases. You would have actually go through all of them and check actually what they support, but always having in mind, if you distribute your data, your queries get slower. But it's really the question, what do you need? I have another example where you maybe think of graph databases would be awesome. So, for example, LinkedIn, you know it, right? They have some suggestions, actually, who you could connect. A few years ago, you were scrolling down, and then there was an end. You just had like 20 or 50 recommendations. And the thing was, they pre-calculated that every night. But the thing is, what happens if a new user comes to this LinkedIn platform, and maybe you know it already, this person, and he starts creating connections there. So I have to wait another day. And now what you can see is we have infinite scrolling. And this is only possible when you do that with a graph database, because you just jump in and then you do live queries. You don't have to pre-calculate. And for such kind of things, you would use a graph database. Are there other questions? Yeah?
Does this database have a defined schema, or is it dynamic? And is there any way to impose constraints? So, for example, Alice cannot have negative number of values.
That's a good question. So in general, NoSQL databases don't have a schema, right? They are adding some kind of uniqueness to nodes. For example, that an email address can be unique or an ID can be unique, but not more. So in the end, actually, the schema is not in the database anymore. The schema has to be in your application, just it moves up, right? So you don't have these constraints. If you want to make sure that your graph is connected the right way, you have to actually have a job walking around and checking this. So at the moment, there are no such constraints, but you can think of even like security checks on some nodes. It actually will make the graph database very slow, because you always have to check for this. And the idea is really, when you use, for example, Neo, that you have damn fast queries. Yeah. Thank you. Good. Not finished yet. And if you want to see, as I told you, I have a whiskey example, so I can show you how it looks like afterwards. I'm still around. Okay, thank you.